A very good evening, everyone, and a warm welcome. Myself, Dr. Mitusha Verma, consultant radiologist at Nanavati Super Speciality Hospital, Mumbai, and I am here with all of you again this evening to start something new, something very interesting under IRIA ICRI webinar series. We already had a lot of Wednesday webinars. Now this is time for Thursday artificial intelligence session. Artificial intelligence is such a topic which all of us now, like since last few years, are coming across and have several doubts about. But this time, with this COVID pandemic going on, we are really looking forward to it. We want artificial intelligence to assist us, to help us do these X-rays, CT scans, triage these X-rays and CT scans, and give us an idea about the suspicion, a level of doubt we can raise over these radiographs and CT scans for COVID scans. So today we have our first session, and the topic will be, will AI replace radiologists? To handle this session, we have two eminent radiologists who don't require any introduction. So we have Dr. Harsh Mahajan, sir. Sir is Chief Radiologist, Mahajan Imaging, New Delhi, and he is the chairman for Center for Advanced Research in Imaging, Neurosciences and Genomics. Sir has several awards to his credit. And to start with, sir is a Padma Shri Award holder, past president IRIA, past president ISNR. We also have with us Dr. Vidur Mahajan, research. Okay. So we welcome you both. Sir is a Padma Shri Award holder, past president IRIA, past president ISNR. We also have with us Dr. Vidur Mahajan, research.
Thank you very much and welcome to this IRIA ICRI Caring web series on artificial intelligence. And can you mute it please from your side, because I'm able to hear the. Thank you. Artificial intelligence, as you know, has been talked about for the last few years, and actually has been scaring radiologists. And over the last 3-4 years, what we've seen that more and more money is being spent on creating artificial intelligence algorithms, but yet there are very few that have come into clinical day-to-day use. However, most radiologists in the beginning were very fearful. Today, I think with the changing scenario in the world, with digitization, I think radiologists have become more open-minded, more accepting. And the future, probably, we will have two kinds of radiologists who have and use AI, and radiologists who do not. And through these web series, we'll try to learn as to what the advantages, what the disadvantages of this technique are going to be. If we talk of the Radiology Society of North America annual meeting in Chicago, 2 years ago, there was only one small corner of one hall was given to companies who were working in the field of artificial intelligence. A year ago, it was about 1/4 of the hall. And this RSNA, last year in December 19, one huge hall was dedicated to companies working in the field of artificial intelligence, and 2 other halls were for all the other things. So it is really coming into its own, and that's why I would like to thank Deepak Patkar, Dr. Deepak Patkar and his team at IRIA, the ICRI team, for having thought of doing this. Now, let me give you a little introduction to what is CARING. CARING is the Center for Advanced Research in Imaging, Neuroscience and Genomics, and for the last 2 years or so are wholly working on the field of artificial intelligence. Caring does cutting edge translational research and product development. They've made a product called Carpal, which is the Caring Analytics platform. It is a dedicated AI division which is focused on AI development, testing, and deployment. Have more than 25 collaborations around the world, more than 7 papers in the last 2 years in premier journals, and more than 90 presentations, papers at RSNA and ECR. There is also another division which is called Caring DX, which is genomics division. And this, to the best of my knowledge, is the first radiology group where genomics has been embedded. The idea being imaging giving us the phenome and genomics giving us the genome, and maybe this is what the future holds. Building research credibility is central, and towards that, Caring has been quite active. This is the first paper ever to be published on artificial intelligence in the Lancet, and this was in October 2018 on deep learning algorithms for detection of critical findings in head CT scans. This is in the Lancet. Then a paper in AJR, which was last year, Concepts in US FDA Drug Administration Regulation for Artificial Intelligence for Medical Imaging. So people from India are really writing and saying, what is the way to get US FDA for artificial intelligence? Then unboxing AI. As many of you will know, artificial intelligence and deep learning is said to be a black box. You don't know what is happening inside. This was an original investigation published in Academic Radiology on unboxing AI, where radiologists actually tried to become the brain of the deep learning network and try to see what it is that is being used to build an artificial intelligence algorithm. And this was the first ever effort in this direction. Then the algorithmic audit, and this was again in artificial intelligence published last year, where again, there are algorithms which are being built, thousands of them around the world, and the person building it will say, my algorithm is 95% accurate or 98% accurate. But when you start using it, you see that it doesn't work so well. This term has been coined by Caring, the algorithmic audit, and this paper actually delved into how can you actually test the algorithm before deploying it in the clinical field. Something like when a new CT, MRI, or ultrasound is installed, you actually go and fine-tune the machine for a few days before you start working with patients. Similarly, we feel that one would need to validate the algorithm, and towards that end, Carpal is the tool that has been built. And this is another paper which is on automatic recognizing cartilage lesions automatically using artificial intelligence. And yet another, latest one, which has been published recently, which is a systematic meta-analysis of CT features of COVID-19, lessons from radiology. This is a huge meta-analysis of 49 papers which have been published recently. So, like I said, more than 90 papers already presented in academic international conferences like RSNA, ECR, and also this Aunt Mini Award, which was won by this group. Can AI generate clinically appropriate X-ray reports? This was in the RSNA, and this was the one paper which was maximally read, the abstract maximally read by radiologists in the entire RSNA, and that's why they won the Rodies Award here. A word about Carpal, and you will learn about this more as we go. for actually deploying artificial intelligence algorithms in day-to-day clinical usage, you need a platform which will go into your computers, into your PACS, into your radiology information systems, hospital information systems. And that is what Carpal is, which is the bridge between data scientists and clinicians. And it helps algorithm developers as well as clinical establishments like radiology departments in using artificial intelligence. The goal of this web series is to equip you with the tools needed to form your own opinions about artificial intelligence. Nothing is going to be, rammed down the throat. We are not going to say that this is good or this is bad. We are not going to say you adopt AI or you do not. That is for you through these series to form your own opinion and hopefully also become a part of the revolution of artificial intelligence, because through this webinar, you will be able to interact with people who are working, whose whole life depends on building and deploying artificial intelligence algorithms. The first talk will be by Dr. Vidur Mahajan, Will AI Replace Radiologists? And this is something we talked about this in the RSNA 1.5 years ago. Then the next one, Does AI actually help radiologists? By Dr. Vasant Venugopal. Then how do I test or trust AI? Something which I alluded to. The validation by Dr. Vasant Venugopal again. And this will be on the 14th of May. And then how to build AI algorithms. Probably what this group is going to tell you, that sitting in your own home with your own computer and maybe with some help from them, you may start building your own algorithms and trying them out. So I'm now going to hand over to Dr. Vidur Mahajan. I'll have actually Dr. Deepak Patkar come in first, and he will introduce Dr. Vidur Mahajan, and then Vidur will take it up from there. Thank you very much, and I hope you really enjoy this series, and hopefully this will be the first of many to come. Again, thank you, Deepak, and thank you, IRIA, for giving me this opportunity to actually chair this session.
Thanks a lot, sir, for this wonderful introduction to AI. Dr. Deepak Patkar, sir, was just about to join us, but he just got an important call. So I think we can go ahead with our session, and Vidur sir can take over.
So I will just introduce Vidur. Vidur did his MBBS from Sion Hospital in Bombay. And then rather than getting into radiology, he decided he wants to do something different. So he went and did his MBA from Wharton, University of Pennsylvania, in finance and healthcare management, and then came back to India in 2016. And for the last 4 years has been working to further expand Mahajan Imaging, new centers, and also as the head of R&D, and has set up CARING, the Center for Advanced Research in Imaging, Neurosciences, and Genomics. And a lot of his time is devoted to artificial intelligence. And I would request Vidur to take you through his talk.
Thanks, Pa. It takes an IRIA webinar to get one's dad to say good things about them. So when Dr. Deepak Patkar sir reached out to us and said that he's thinking of having a web series on AI, and it's part of the mandate of IRIA to actually educate its members and the world at large about latest technologies, and AI being one of them. I thought that it might be useful to start with somewhat of an introductory session, but then start in a way where you hit the nail right on the head and just settle a few doubts and then move on to getting into the technical side of things, which is why literally we named the first talk "Will AI Replace Radiologists?" because this has been much debated, and my intent frankly would be that at the end of this talk, this debate is kind of laid to rest so that we can for the balance 3 talks that would happen over the next 3 weeks, we focus more on some technical insights, learning about what's happening in the world, and then lastly, how as radiologists you can start building some of the algorithms yourself. So with that said, this whole replacement issue actually started with Professor Jeffrey Hinton, who is one of the fathers of deep learning, saying this statement, and I will just read it out. He said that I think if you work as a radiologist, you are like Wile E. Coyote in the cartoon. You're already over the edge of the cliff, but you haven't looked down, and there's no ground underneath. And he went on to say that people should stop training radiologists now. It's completely obvious that in 5 years, deep learning is going to do better than radiologists. And this led to a huge furor, and people all over the world were very intimidated. These were very strong words. And instead of taking 5 years, then in 2017, Professor Andrew Ng, who is also one of the leaders in deep learning and AI, published this paper. One of the lead researchers was a guy called Pranav Rajpurkar, very, very amazing researcher in this domain. But then, again, Professor NG also started by saying, should radiologists be worried about their jobs? Breaking news, we can now diagnose pneumonia from chest x-rays better than radiologists. And then very soon after this, Vinod Khosla, who is one of the leading technology investors in the group, in the world, he's also invested in a few AI startups, said that, doctors and especially radiologists, so he actually said radiologists and oncologists will be obsolete in 5 years. And this was said on April 7, 2017. Of course, once these statements are made, there are reactions. This is a guy called Dr. Hugh Harvey, again, one of the thought leaders in AI. He's a radiologist. He wrote this post on why AI will not replace radiologists. This particular quote has been doing the rounds. In fact, Dr. Mahajan also used it, that AI will not replace radiologists. However, radiologists who use AI will replace those who don't. This was said by Professor Kurt Langlotz from Stanford. And, then even the Harvard Business Review put out an article, and this was one of the co-authors was Professor Keith Dreyer from Harvard Medical, and they said that AI will change radiology, but it won't replace radiologists. I hope I wish they had picked a better background image than this one. So the debate was all over the place, and the cartoonists jumped into the entire situation by hitting the nail on the head. I believe that this is an image. The ultrasound machine, I think, is saying to the radiologist that, hey, I'm being sued for a misdiagnosis. What do I do now? And the doctor is just saying that, sorry, buddy, that comes with the job. And I think this is going to be one of the key factors or one of the key discussion points of our conversation today. We played our part as well. This is Vasant at the Airy Crown Theatre about 1.5 years ago at RSNA, talking about the mirage of AI substituting radiologists. Lessons from when AI got it wrong. This is because in our research group, we work with so many companies that, we do have this kind of insight. And he was about to say this statement, which he did not, but he has given me permission to say it today, where, he was going to say that given the speed at which AI is developing and at the speed at which radiologists are getting involved in AI, maybe it is not the radiologists who need to worry about their jobs, but maybe it's the computer scientists. So that was a fun kind of statement. We ended up not using it for obvious reasons, but then I have permission to say it today. So the short answer to this question is no. So if there is anybody here who had logged in to just get the answer to the question, the answer is no. AI is not going to replace radiologists. And the long answer, as it is generally in life for most things, is that it depends. And we'll try to go into what are the factors behind this dependency and how one can answer this in a very scientific and logical way. But before going into that, I would like to just set the stage as to what is meant by AI, what is artificial intelligence, so that we are all on the same platform, because the meaning of the word has been changing quite rapidly. And the term itself was coined in 1956. For our conversation today and over the next few weeks, AI will refer to the ability of computers to learn without being explicitly programmed. And what this means is that let's say in the context of a chest X-ray, you don't really need to tell the computer that the heart is normally on the right side of the image, but the computer automatically learns that fact by looking at enough chest X-rays. And the same thing applies to anything at all. Also, AI has gained recent popularity, one, because anyone can do it. Deep learning as an approach, as Dr. Mahajan again mentioned, we'll be trying to teach all of you how to use it over the course of these lectures, and literally anyone can do it. Right? It's really becoming very, very accessible, and you combine the accessibility of the technique itself with the exponential increase in computing power that we are all seeing. Right? Our phones today are 1 million times more powerful than the computers that sent Apollo 11 to the moon. So basically, in a nutshell, AI is nothing but using extremely powerful computers to find patterns in data. They may be hidden, they may be very much visible, but it's just automatic pattern recognition. And it also has significant overlap with the field of computational neuroscience. So many of the concepts, many of the basic research is actually, again, artificial intelligence. So it has to be neuroscience, is coming from that domain. But what I particularly find most interesting, and the definition that I agree with most, is something I found on Wikipedia, which is AI is whatever machines can't do yet. And I find this particularly interesting because in, let's say, if in the 1950s or 1950s, somebody would have turned up with a scientific calculator the way it exists today, like just a regular calculator, or even a non-scientific accounting calculator, and somebody standing there and says, okay, I can do 2,035,448 to the cube root in half a second, it would be definitely considered some form of artificial intelligence. Today, we don't even think of it as being AI, because it just happens, it just works. So similarly, it's extremely possible that 4 or 5 years down the line, 10 years down the line, there is somebody again giving such a lecture, and we are again talking about how AI is going to replace something, and the context might be entirely different. And at this point, I just want everyone to think about, have you used AI in your life ever? Right? And many people are able to figure it out. Many are not, because it has become so all pervasive in our life. But whenever you use Google search, to go from anywhere to anywhere, you are possibly using one of the most sophisticated forms of AI that exists today. The same thing applies to even something as simple as these automatic typing recommendations. In fact, now Google has started including recommendations in emails. Like as you are typing an email, you can literally, it predicts what you might be saying next. And Google search is also the most powerful form of AI you can probably imagine, right? It's as if it knows what you're going to search for, right? So these are Netflix, Uber, Amazon, all of these companies, all of these technology companies are using AI, and as a matter of we are using AI, and many a times we don't even think about it. Like I don't think that the Uber driver who's using Google Maps to go from point A to point B is actually thinking that he's using some form of AI. So that should be the goal also for healthcare, for AI to become so embedded that we don't even know that it exists. And over the next few weeks, we will try to point out such examples to you, and hope that it might just surprise you. There are three types of AI. There is artificial narrow intelligence. This basically refers to where computers are today when they are very good at one thing. So for example, playing chess, computers are amazing at chess. Human beings can never beat computers now at chess. But then, Deep Blue, the computer that beat Garry Kasparov, can only play chess. It cannot do anything else. So that is what is meant by narrow intelligence. YouTube can only tell you which video to watch. It can't tell you anything more than that. Or in the domain of radiology, a chest X-ray AI algorithm can only look at chest X-rays. It cannot look at CT and MR or anything else. So this is what is meant by artificial narrow intelligence. And this is where computers are today. Then the next domain is of artificial general intelligence. This is where human beings are, right? We can do multiple things. We can sing, dance, talk, walk, think, read CT scans, click pictures, do a bunch of things, and the same person is doing all of those things. So we are generally intelligent, narrowly intelligent in some bits, but generally intelligent otherwise. And this is the next frontier in computer science. There's almost a semi-arms race going on globally between a few companies to perfect this, but we are nowhere near this right now also. And then comes the domain of artificial superintelligence, which is what happens when you merge narrow intelligence with general intelligence. So a computer system that becomes generally intelligent in everything, right? And the world is this is like the Matrix comes or computers take over the world, that kind of scenario. The world is very much divided on it. We definitely know it's not happening right now, because it would have certainly come up with certainly come up with a solution to coronavirus, or maybe coronavirus is the solution. But generally speaking, these are the three fields, subcategories of AI. And just again, think of these frameworks that I'm giving you as you go through both this web series and also in general when thinking about AI. Another framework is around applications of AI. So there are essentially two broad applications of AI, or two broad categories of applications. The first is what humans can do, but AI either does it better or does it faster. That means it's most easily understood by CCTV cameras, right? Human beings can literally look at CCTV cameras all day long. Maybe we can see 4, 8, maximum of maybe 12 to 16 cameras at a time. A computer can see millions, right? We have heard enough about this happening in China, especially in coronavirus. In India also, now certain government agencies are trying to use this to figure out social distancing and all of that. It's just not possible for a human to do. right? Well, it is possible for a human to do, but not at that scale. So these are tasks that humans can do, but machines can do them better. The other task is of translation. We can sit all day long and translate, some books from, say, English to Hindi. Google Translate just does it instantaneously, right? Zero effort. And then there are things that humans just cannot do. And again, I use the example of Google Maps, where, I can probably tell you the way from one place to another, but I cannot tell you exactly how many minutes it will take you to get there, what is the most optimized route. And just because the number of parameters that go into making that decision are so many, that it becomes it's next to impossible for a human being to do it. In fact, we can't even figure out why the AI is trying to give us a nudge in a particular direction. And that's what is meant by, like, these are the way to think about it again is these are all AI applications that are not magic. You can go back, you can check, you can figure out why the AI may have done something, where did it go wrong. Whereas these ones are pure and simple magic, right? Like there is no way for us to figure out why the AI is saying something or how can we fix it. Or of course, it's a lot of trial and error that goes into it, but just the parameter space is so much that we can't really figure it out. Next, just a quick 1.5 minute primer, and we'll be going into much more detail on this, but on how an AI algorithm is created. It starts by finding data. It's the most important step. So let's say we are trying to create, again, a chest X-ray algorithm, and Dr. Patkar gives us 100,000 chest X-rays, and we are now to make a normal versus abnormal chest X-ray algorithm, and let's say 50,000 of those are normal, 50,000 are abnormal, and we have found this data and we have the associated labels. Then we go ahead and train a model. So these are, basically you take some 80% of that data. So you will take randomly 80,000 X-rays out of that, 40,000 normal, 40,000 abnormal, and you will then tell the AI algorithm to go through those 80,000 images and try to form hypothesis around what are the commonalities between all the normals and what are the commonalities between all the abnormals. And as it does that, as it goes through each X-ray, the AI itself tries to figure out why a certain label has been assigned to a certain X-ray. And at the end of one round of going through those 80,000 scans, the AI comes up with a hypothesis. And then on the balance 20,000 scans, that hypothesis is tested, right? And let's say the initial accuracy comes to 60%. Then again, the AI goes back, it changes certain things in its hypothesis, goes through all the 80,000 scans again, comes back here again on those 20,000, checks again, now it's 70%. And this cyclical process keeps happening again and again and again inside these tiny supercomputers. And at the end, you have a model which finally on this validation set of 20,000 X-rays has an accuracy of, say, 95%, right? And you are very happy you've made an X-ray algorithm yourself from scratch. But then comes the ultimate test, which is taking this AI algorithm to the hospital across the road and running it on 5,000 scans there. And then you will realize that, oh no, it's come down to the accuracy has actually come down to 70% because all the images that you trained on were DR images, whereas at this hospital, all the images are CR images. Or, there can be something completely different. This was an urban hospital. This was a rural hospital. This was a, so just to give you the sense that this is the typical flow. And then once you test, you get, you realize that your model is not working, you go back, then you test again, you go back, you test again. So this is a cyclical process that happens over the life cycle of the AI. And we'll go much more in depth in this over the next sessions. But then coming back to the replacement question, right? What are factors that will drive replacement? So I think essentially it comes down to a merger between what does a radiologist do and what can AI do. If there is an overlap between these two, then yes, there is a chance for replacement. Otherwise, no, there is no chance for a replacement, right? Because and then you need to go deeper into what are the tasks that a radiologist performs, and what is the complexity of each of those tasks. So, because you can be doing very simple tasks that are not complex, which maybe AI has the capability to do, and maybe there is utility to do that, or you can be doing extremely complicated tasks that only you can do, and AI doesn't have the capability to do that. So whenever thinking about replacement, think about, you will have to go a lot into granularity to figure out, what exactly is it that is being replaced, and does even AI have the capability to do this? And to take that further, there are essentially three things that a radiologist does, and again, this is open to infinite debate, but just for this particular discussion, there is communication. So there are communication related tasks, there are perception related tasks, and then there are cognitive tasks. And what does that mean? Communication includes, it, talking to patients, talking to doctors, talking to colleagues, talking to staff, generally communicating with the world, learning, educating, gaining education. All of those things come under communication. Then there are perceptive tasks. Now we're getting into your actual job, right? And that includes pathology identification, pathology detection, pathology segmentation. So these are all tasks that are happening in your brain, but this is just perceiving, right? You are just drawing data points out of the images. And then comes the most beautiful part, which is cognition, where you are diagnosing a disease, where you're putting together everything that you are learning from communicating with the patient to perceiving the images, and then making a diagnosis. And this is a lovely statement. I think Dr. Ravi Ramakant says this often, that you are diagnosing patients and not images. So this cognitive aspect is kind of testament to that part. And where is AI, right? AI is impacting only small pieces of this puzzle. In communication, there are chatbots, there are dictation systems, maybe there are report alerts that are coming. And communication per se affects the entire medical fraternity, not just radiologists. Perception, and again, I say we will go very deep into each one of these in the next sessions. But this is more to lay a framework, right? So communication, perception, there is automated lesion segmentation and identification is happening. People are doing it for chest X-rays, chest CTs, brain MRs, multiple sclerosis, tumors. A lot of work is happening in this. Many of these tasks you may not want to do, right? We use a tool that automatically segments liver on triple phase CT scans for pre-liver transplant donor evaluation. Nobody wants to do that. AI does a fairly good job, so we use it, right? So this is on the perception bit. And then on cognition, again, very, very limited AI impact, just because it's also much more complicated a field. There are automated pre-reads that are happening, normal versus abnormal, real-time quality checks, tuberculosis is being diagnosed, head CTs are being reported. A lot of work is happening, but very, very minute pieces of the puzzle. And in the next session, Vasant will go very deep into these two aspects of the situation. And then there are tasks, as I was mentioning, that radiologists just cannot do. For example, predicting patient wait times and appointment delays, right? This is a paper in AJR where, again, they say that, using machine learning algorithms, you can predict how long a patient has to wait. Similarly, we created an algorithm to create diffusion weighted images from T2 weighted images. And the idea being that can you delineate acute and chronic infarcts on T2 weighted images, right? So again, it's very much under research, but something radiologists just cannot do. Then we are working on an algorithm to synthetically generate PET images from CT images. Again, something we can't do. GE has started embedding deep learning based image reconstruction into their CT scanners. We don't even see it because it's basically sinogram images going to DICOM images, but something we just can't do. Subtle MR is using, they are a company based in San Francisco. They're trying to create good MRI images from bad MRI images. So just to say that there are enough number of tasks that AI is embarking on doing that are beyond the domain of human capability. And another framework to think about replacement is, again, this is more from a workflow perspective. There is the whole pre-scanning part of radiology, which is patient scheduling, preparation, waiting time, giving the patient appropriate instructions and all of that. Then comes the actual image acquisition, where you have these MR recon techniques, CT recon techniques, automatic MRIs, a bunch of things that are happening. Again, nothing to do with radiologist replacement. Then there is the whole post-processing and analysis side of things. Again, has very limited to do with what a radiologist does. And then lastly, is diagnosis, which is where the radiologist, or dare I say the clinician, comes into the picture. So again, just another framework to think about when somebody comes up to you and says, hey, radiologists are going to be replaced. You need to know where exactly it's targeting. And then even within the technology community, there is a definite mindset shift. Earlier, there was a belief that radiology is just seeing images and telling what's wrong, right? And once these engineers start going deep into it, I think this just is the only way to summarize it. Oh, this is complicated, right? And then, many people just give up that. And we have seen this happen time and time again, that you start by saying, oh, it's just an image. And then you realize that, no, it's much more than that. And another interesting shift is till a few years ago, it was more about building products to replace radiologists. Right. And I know this for a fact that, within the tech community and the venture capital community, this was a real belief. They truly believed that they can do this. And now it's more about building products for radiologists. So again, there is this huge jump in mindset that we are seeing on the tech side of the world also. And don't think replacement, think augmentation. And Dr. Patkar named this series in this way. And I would like to draw an example from the world of lab medicine, right? This is a Roche auto analyzer. I think it can do 1,000 samples a day or something. And all these 1,000 lab reports are approved and signed by a pathologist in a single day, right? Why? Because there are strong quality metrics in place. At every point there is a QC parameter. Lab techs are learning statistics. Pathologists are learning statistics. Anybody who's a lab quality head has a basic knowledge of operational statistics, and that's what enables them to pull off this entire scheme, wherein a single pathologist confidently signs off on thousands of reports. Think about how a radiologist can sign out 1,000 reports, right? Push yourself to that. If you're reading 50 MRs a day right now, what would it take for you to read 500, right? Please think about that. And getting AI into the clinic is also not a trivial task, right? There are hundreds of companies developing AI for radiology. These are most of the companies that were there at RSNA last year. But how many are you using, right? If you're really privileged, maybe you're using one or two of these, but where are the others? Why are they not coming in? So that brings us to the challenges that are there at every level. There is a challenge to access algorithms. There's just too many of them. How many of these 100 can you actually reach out to and work with, right? There's just too many algorithms. People are making their own algorithms. There are open source algorithms, just too many. Let's say you get access to them. How do you test the algorithms? How do you interview the algorithm? Does it work? Does it fail? When does it fail? How can you figure out and predict when an algorithm is going to do well or not do well? Very similar to how it works when you're getting on board a new colleague, right? If you're hiring somebody, you need to know when they're doing well and when they're not doing well. So how do you test AI? And let's say you've crossed that bridge. How do you integrate it all into your workflow in a seamless way, right? How do you work with the PACS, the RIS, the HIS? We'll be covering a lot of this over the next few sessions. But just to point out that these are the challenges. So in summary, and this is just the summary for today, the summary might evolve with time. As of now, AI does not have the generalizable intelligence required to do what a radiologist does. So let's not worry about replacement, right? Let's not even talk about this. It's not going to happen. And you know, even the day it does happen, just imagine the entire like radiologists sit, and luckily I'm not one, so I can say this. Radiologists sit at the top of the cognitive food chain, if I may, right? Imagine what else would have been replaced by the time radiologists get replaced. So please, let's not talk about this anymore after today. That said, think about tasks you would rather someone else does for you. Our favorite, especially in our centers, are hanging protocols, right? Like this request has come in multiple times that, you know, you're developing all of this fancy AI. Why do I still need to, you know, pull all these cases to images together and put them into appropriate boxes and all of that? Why can't that happen automatically or something like that? So think about tasks you would rather not do, right? And when thinking about AI or its application, think what part of my job is it targeting, right? And even if it's targeting something menial that, you know, don't even think about it. So, you know, this is just to say that it's very important to be very specific about these thoughts. And most importantly, everything that I have said till now relies on the fundamental premise that a radiologist is more than just a text report. And Dr. Mahajan also says this many times, but you need to be a doctor who diagnoses patients and not images. So a text report is very easy to replace, mind you. In fact, our paper that won us the Aunt Minnie Award was exactly on this. So a text report is easy to replace. A person, a doctor, not so much. So, with those thoughts, you know, I'm happy to take on any questions, and feel free to write to me. This is my email address, vidur@mahajanimaging.com. We are always looking for people to collaborate with. We have, especially with COVID-19 on our heads, we have more than enough work for volunteers in AI, non-AI, otherwise research. So please feel free to reach out to us. Thank you.
Thank you, Vidur. Am I audible?
Yes, sir.
Yeah. So I want to thank Vidur and Harsh for a very, very nice session. Good evening to all the members and non-members of IRIA, my friends and colleagues. These are very, very trying times. I know all of us are going through very, very difficult circumstances. We, in spite of all these problems, must work like frontline workers. This will help us build our image. People must know what radiologists are doing during this trying time, and we must work as a frontline workers whenever possible. At our institute, as we talk, I have 107 patients admitted, and all my residents are doing COVID duties. All the consultants are working full time and doing COVID X-rays, CTs, and ultrasounds. So we, whenever get opportunity, must identify ourselves, take us further, and be on the front line. In spite of all these problems that we are facing in terms of not being able to do outreach activities, I thought we at IRIA and ICRI can use an opportunity to reach all the members through webinars, seminars, etc., whatever we can do using the current technology. Education must go on, that cannot stop. My daughter is in 12th and all her on-site classes are converted into offline and she's working at the same speed. So we should not get bogged down by these problems. Before COVID, radiologists were wondering whether AI will kill us, they will get us out of job. Now people are scared to reach their own centers and start doing scans. People are looking for teleradiology solutions. So things have turned turtle in last 2.5 months. Digital platform is really helping us, and we are probably the best ones amongst doctors community to use it. Thank you, Vidur and Harsh, for letting us know what is the current status of AI in India, whether AI will replace radiologists or no, and many more. There are a few questions. There are about 8-9 questions that have come up, which Mitusha will share with you and you need to answer. Before I close, I request all of you to become IRIA, ICRI members and take opportunity and become members of our social security scheme. Stay safe, keep distance, stay healthy, work as hard as you can. We at IRIA and ICRI are planning to have 2 to 3 webinars per week covering 2 to 4 lectures. This Sunday, we have a full day session on oncoradiology starting from 9, ending at 6. So take help of that. We have about 2,500 people registered already, and I'm sure a lot will get added up. So in spite of all these problems, we are able to reach a lot of people, and I'm really proud of that. Long live IRIA, Jai Hind. I'll put 2 questions to Harsh if he's there, and Vidur, we have 6 more questions. Is Harsh there?
Yeah, I'm here.
So 2 questions. One, how good are the AI protocols available for COVID-19 as we talk now?
See, as we talk now, there have been claims by some people about having developed COVID-19 AI algorithms on chest X-ray, also on CT. But, they haven't published anything. These are just media reports that have come in the lay press, not anything technical. And having looked at them slightly closely, they have taken just a few cases and developed something. So I don't think these claims at the present point of time can be taken very seriously. At the same time, what I would
we
say,
should rely on our own knowledge and abilities to pick up COVID.
Yeah, we have to. I'm just coming. Actually, along with CSIR, Caring is working at 2 things. One is to actually take all the data about all COVID patients admitted in hospitals across the country. First, collate the data, then analyze it. And this would also include, clinical data, lab data, X-rays, everything, and ultimate result. And after analysis, find out what worked, what didn't work, what went wrong. And the second part is that we are actually building AI algorithms for chest X-ray. Because on chest CT, it is still relatively simpler. And chest CT is not a diagnostic tool for COVID-19, as has been now, as per guidelines of so many, societies across the world. And even when it was said to be very diagnostic, 34% of all cases in one large series, which were called COVID, were actually some other pneumonia. So, but definitely X-ray as a OPD procedure, someone comes with fever and cough, and if you do a chest X-ray, and if an AI tool can actually help you in making a provisional diagnosis of COVID so that you can separate out of 100 X-rays done, maybe only 10 go for RT-PCR, then it would be very useful. And maybe that's where the future will be. So we are building that, and probably Vidur can tell a little more about it, because we are looking for Indian data.
Actually, why I'm asking you this is BMC was planning. So PCR is getting difficult and it takes 2 days because of a lot of logjam. So they were looking at taking 1 lakh plus X-rays per day in areas like Dharavi and where population is dense and it's impossible to do PCR tests, and segregate people exactly like what you are saying. So segregate them into definite, who can go to hospital, suspicious, who will go for PCR, and normal, who can be excluded.
The challenge is that so we are actually faced with the same issue, that if you look at visual features, you may call that it's highly likely that you may call someone as normal, but they are asymptomatic carriers, right? Which is actually the biggest issue with the COVID-19, that the asymptomatic carriers do not have any lung lesions per se. Which is very different from tuberculosis, because many of the AI companies and many of the well-respected ones are extrapolating fundas of TB to COVID-19, which is maybe not the ideal method. That said, sir, the role that we are seeing is in at least finding pneumonia, right? That is definitely you can find pneumonia, whether it is viral, bacterial, typical, atypical, etc. All of those things are separate, but at least you can find pneumonia, and then you can quantify findings in the ICU also. So there is a role, but it's not as much as we would hope it would be.
Right. Mitusha will take the other questions.
Thanks, Deepak.
Yeah, I'm around.
Yeah.
Thank you, sir, for such a wonderful lecture, that we could actually get an idea of what AI is all about. And with forthcoming sessions, definitely we will move ahead into this field of AI with all of you. So there are pretty like around 10 to 12 questions which have come up. So one is that what are the career prospects with AI? So like as rightly Dr. Vidur pointed out, that after radiology training, he went into AI. And so as
just to clarify, I am not a radiologist. So I did my MBA after MBBS.
Okay.
I'm not. Maybe that's why I can spend time on other things.
Okay.
otherwise, I would be reading.
Yeah, so maybe we have done the 3 years of radiology. So now, if we want to go into AI, then how to go about it? Yeah.
I would say there are various ways of doing it. Maybe the most easy is to become an advisor, either in an academic institution or with a startup. There are many startups out there that are looking for, as I say, clinical gyan. And that is one way of segueing into it, like 4 to 6 hours a week you can start giving to these startups, and exploring how you like it. The other way is that you can, as a hobbyist, start creating some AI. It's becoming very easy. And the third is, if you want to work in it full time, reach out to me. So, because honestly, because if somebody wants to do this full time, it's a very big decision, because you are almost giving up on clinical practice. So it's more of a technology role. It's very, very different from routine clinical practice. So reach out to me, and I'm happy to share thoughts.
Just to add to that question, something like this, how many vacancies you will have across the world or in India, just for people's knowledge, and what are the salary structures compared to?
Sir, your voice.
Yeah, sorry. So just wanted to, I'll repeat the question. Want to know, for people's knowledge, how many vacancies like that you'll have. So your company will have, say, X, multiplied by how much? That is one question. Part of that question is a freshie coming out of medical college, MD or DNB, will earn X amount of money. So what you all offer is X only, or 1.5X, or half X?
Sir, so questions are a little difficult to answer. First one is relatively straightforward. So, sir, like all of these companies like GE, Philips, Siemens, Fuji, etc., all of them also have radiologists as full-time employees helping in their AI divisions. Companies like ours are very small. We can maybe take 1-2 people, maybe not more than that. But then there are also larger AI companies that are now emerging that can hire. So I would say that if I was to just give a random number, I would say it would be in the scale of, say, maybe 100 to 500 vacancies globally. But that would be for full-time people. If you want to do it part-time, say 1 day a week, 2 days a week, sir, there are many of our friends also who are radiologists who do that with the big companies and the small companies. The second question about remuneration, sir, so unlike healthcare, in the world of management and technology, remuneration is very much linked to the value that you bring. Right, in healthcare, sir, it's very easy to quantify that value. Acha, tumne 100 case pada, tumne 50 case pada, so you should be making half the amount of this guy. Whereas in these fields, it comes down to not just your skills as a radiologist, but also other skills. Right? Let's say you are a radiologist who is great at selling technology. Right? Then, because selling is the thing that brings the money in, it's possible that X is actually 4x, 5x for all you know. Whereas, if you are a typical, by typical I mean, somebody who's like a general radiologist just wanting to experiment, and because of that wants to change their job profile, it can possibly be 0.8x.
Got it.
We can actually see a lot of responses coming in. There are quite a number of people interested to join this field. So they're asking part-time, full-time, and I think your answer had...
So you already have 20 applications.
Yeah. So going next into the same direction, people are asking that there are courses available, even like we keep on getting mails from good institute or maybe like the authentic ones or not, to train them in this field of deep learning, AI, some degree courses kind of correspondence. So do you suggest the radiologists to undergo those courses and then join? Will it help?
Yeah, so again, in this world of product development and technology and all, degrees matter less, skills matter more. So my advice would be, there are some great courses on Coursera by Dr. Andrew Ng's group. I'll just write the name here also. In fact, one recently they came up with on this. Deeplearning.ai is the website where they have specifically put out a healthcare AI course. And I think it's free for anyone who doesn't want a certificate. So those are much more helpful than, paying lots of money for a degree. Because eventually, what matters here is that you need to build something that works, or you need to build something that is useful. So it doesn't matter if you are a MBBS student or if you are, a MD, PhD, whatever, who is doing it. The market will reward what works. So invest invest time more than money is what I would say.
Correct, sir. So I think that is a perfect way of addressing what people are asking about. And also there are questions that there are multiple off-shelf AI platforms, like maybe freely available or sometimes at a minimal charges. So should they be used while suppose in private practice, or should we use them to create our reports?
So that is a very, very good question. The thing is, the off-the-shelf or open source algorithms that are there, they need to be tested, because at the end of the day, it is your signature that is going on the report. So if you think there is something, so I'll give you an example of how we use open source AI. Right? There is again, the Stanford group has released this algorithm called ChexNet. Which is an open source chest X-ray algorithm. It gives out, 14 common abnormalities: pleural effusion, pneumonia, pneumothorax, etc. Now, for some particular research project, I needed to extract 500 pneumothorax cases from my packs. But because of some data issue that I had experienced in 2016, pre-2016 reports were not available to me for that particular hospital. So we literally took out some 100,000 chest X-rays, took this open source AI algorithm, ran this open source AI algorithm on those 100,000 chest x-rays, and all the x-rays where this algorithm with a very high degree of confidence said that pneumothorax is present, we simply reviewed those and found the 500 cases that we needed. So, it is a very non-clinical application. No patient is being affected, nothing at all, but the job is done. So you'll have to think of what is the problem that you are trying to solve, and then look at what is the optimum solution for that, rather than having a solution first and then trying to find a problem to solve with it.
Yeah, and there are questions asking about differences between deep learning and AI. I think Dr. Vidur already addressed that, and he has mentioned deep learning is a method using which AI can be achieved, and AI is more descriptive term, whereas deep learning is a technique. So hopefully, people got the answer.
Very, very quick thing on that. So, simplest thing to understand is that, like I said, artificial intelligence is constantly changing, right? Like, what is artificial intelligence today may not be artificial intelligence 10 years down the line, because it might become very, very, ubiquitous. So, so artificial intelligence is a descriptive thing, right? Something that you think should be done by humans, or something that humans do is now being done by machines, is artificial intelligence. Deep learning is a way of achieving that. So deep learning basically refers to the ability where computers can look at large amounts of data and figure out features themselves. So the X-ray example that I was giving, where let's say you have 100,000 chest X-rays, half normal, half abnormal, deep learning will automatically figure out which are the normals and which are the abnormals based on features that it picks up itself. So it's just a way, it's a method, whereas AI is more the descriptive term.
Great. So there are a few more questions, but I think there are many more sessions. We are going to have you here with us every Thursday for this month. So with Dr. Patkar's small address, we are going to end this today.
Thank you. Thank you.
I have a question for Vidur and Harsh. Try to get people from industry in addition to you, who will talk about career options. Somebody from maybe Harvard, or I'm sure both of you have a lot of connections abroad.
We'll get them all.
Time is not very bad. It must be early morning. So if this time, next over 2-3 weeks, if you can get somebody from Harvard or where deep learning is really going in a big way, our students will get encouraged to enroll and learn it.
That's a great idea. They will be more than happy to. I know people who will be more than happy to come on board. So we may change the structure a little bit, sir, of the.
Yes, maybe not for next week, week after, and we can publish it more.
There's no problem in doing next week also, because they are close friends.
Yeah.
So
whatever time suits them, we can थोड़ा आगे पीछे भी कर सकते हैं आधा घंटा.
Yeah.
चलेगा, sir.
And publicize it well.
Yes.
Yeah. Thank you.
Great.
Thanks a lot.
Thank you.
Thank you.
Thank you, Dr. Videsha.
Bye. Bye.